Happi House, presented by Creative Kid Stuff. We are looking back at some of our favorite experiments with our scientist, Liz Heineke. We're going to do tie-dyeing mess-free, learning about circuitry with our favorite scientist, Liz Heineke. She's going to show us another fun experiment that's easy to do at home. Stay tuned. Hi, I'm Happi. I learned early on things are much easier with a little help. I also have a few tricks of my own to share. It's go time, people. Welcome to the Happi House, presented by Creative Kid Stuff. I am a huge fan of tie-dye. We do it every summer. It can be a mess, and I'm fine with it, but I love your solution to it.
True, it's not messy, it teaches kids about science, and best of all, it combines art and science, which I absolutely love to do.
And summer wearables. It is science time on the Happi House, and we have one of my very favorite people and super smart scientists, Liz Heineke, author of 2 amazing books that makes science really accessible for kids and parents, because I think actually kids are a lot of times more open to experiments than parents are.
Oh yeah. Parents are afraid of science because it sounds hard and it sounds like you have to go out and buy a bunch of stuff. Not true.
Not true. We're going to do something really fun today. It looks like it's going to be a colorful experiment.
It is. It's sort of a faux tie-dye. So It's not true tie-dye, but it's equally fun and a little less messy, honestly.
I love tie-dyeing, but before we get started, Liz, can you start us off with your song?
I can. Are you guys ready to sing?
Yeah.
Okay, repeat after me. Physics, biology, chemistry, yeah, physics, biology, chemistry, yeah. That was awesome. High five. Woo woo, nice.
It's not many scientists that can play the ukulele and the banjo.
Yeah.
And sing. You're kind of, it's a lot, Liz.
I know, I'm a little crazy. It's true.
All right, so what are we doing here today?
So today we are doing magic marker tie-dye. And to do this experiment, you need permanent markers. Because the science behind this is that permanent markers will not dissolve in water, right? That's why you hide them from kids.
Correct.
Okay, but for this experiment, you need them. We are going to take some cotton t-shirts. You could also do shoelaces or cotton socks, like soccer socks. We're gonna draw different colored permanent marker dots on them, okay? Then we are going to use something called a solvent. Can you guys say solvent?
Solvent.
A solvent is a chemical that can dissolve other things. So, safety warning, always supervise kids when you're doing this experiment. It's best to do it in a well-ventilated area, but you can read the warnings on the bottles.
Okay.
Okay, so what we're gonna do first, you guys pick some markers. We are gonna make spots of color on these t-shirts. So go ahead, you guys, grab some markers. Let's make some colorful spots. All right, so what do you think so far, Happi? Is this hard?
No, this is not hard.
Is this scary?
And I love permanent markers.
I do too. What do you guys think will happen if we put a color around a color?
Maybe they'll mix together.
That's an excellent guess. We're gonna test that hypothesis, right?
Yeah.
All right, so once you've put several dots of color on here, we are actually going to use rubber bands and mason jars to suspend the fabric over the jar mouth. So can you help me put this rubber band on? I'll hold the jar. When you're doing science with kids, always let them do stuff. Don't do everything yourself.
Okay, so here's this. Do you want to try to put this rubber band over the top?
And I have some droppers to do this experiment with, but you could also use a spoon or something to drip the alcohol if you don't have droppers. Okay, so guys, we're gonna pick up a dropper, and kids sometimes need a little help learning how to use droppers. Tell them to squeeze it, put it down under the liquid, right? And then let go. Squeeze it, put it in, you got some. And then we are just gonna drip it right on top of these dots of color. What's happening? What do you see happening?
Do you see that?
The color is spreading out.
Exactly. And do you think all colors spread out the same way?
No.
The little pieces called molecules that make up ink are different sizes. So smaller molecules will get carried out faster on the edge of the ink, and bigger molecules will stay behind closer to the center. What if you put like blue and red and green and orange all in one dot? What do you think would happen?
Maybe they'd overlap each other.
Yeah, and do you think maybe colors would spread out and separate into different colors? depending on how fast the molecules travel. And what if you put orange marker on your t-shirt and put drops on it? Do you think it would separate out into what makes orange? Yellow and?
Red.
Yeah. So these are some good experiments. Let your kids try. They can learn about color. They can learn a little bit about chemistry. When you're done with this, let your shirt or your cotton item dry completely. Can you see how pretty that looks?
Yeah.
Let it dry completely. It has to be 100% dry because alcohol is flammable, right? Yeah. Once it's completely dry, you can put it out in the sun or put it in the dryer actually to set the color. And then you can wash it and the color will stay more or less
The same.
the same. So you can make, I actually made one of these and wore it under a blazer. It was super cute.
I love this project because I love to tie-dye, and actually I'm one of those people who's not afraid of mess. However, what's super cool about this is it takes longer than tie-dyeing. So it could be a project for like not a whole day, but you know what I mean, like an extended project for a birthday party. And you're right, there isn't the mess.
Yeah, and it does take a long time to cover a whole t-shirt or bandana or baseball cap.
We made the green. Do you see that?
Pretty, look at that. So science meets art. It's my favorite kind of project.
Yes, this was lots and lots of fun. Thanks for being with us today, Liz.
Thanks, Happy. So it's really fun to let kids play with electricity, and they can actually draw pictures that will light up an LED. How cool is that?
It's actually awesome, and they can understand electricity without being in danger. Not that we put our kids in danger, but it's a very safe way to learn about electricity.
Absolutely.
Yes. It's all about science today with our friend Liz Heineke, my favorite scientist ever. Because you make it so
Really?
fun. Yeah, for real. So what happens when we do science with Liz is a lot of laughs, but a lot of learning.
True.
Ladies, are you ready to do some? You're already kind of getting
Yes.
started. Yeah. Liz is going to tell us exactly what is happening right here, because basically we've written on this paper.
Yes.
And now we're making lights light up. I'm not clear on why. So you're going to explain this?
Yes, I am, to the best of my ability. So we are making circuits on paper using graphite pencil. So graphite is the same metal that you find in lead, right? But it can actually carry electrons, so it can make a path for electricity to flow along. And a circuit is just a closed path, like a loop, that electrical current can flow through. So you can see that I've just bought at the hardware store a couple of these alligator clips,
Okay.
which are basically just wires hooked onto clips, and then they're insulated, so they have plastic over them.
Got it?
And then at a local hobby store, I bought some little LED lights, right?
These guys right here.
Yep. And then 9-volt batteries, like the kind that we all have in our smoke detectors, right? So you hook the two ends of the two different wires up to your battery. So you can see, if you look at this, you can see that we're making a loop, right? A loop of wire that the electrons from the battery can flow through.
Got it?
But to light this LED light that I have here, we need to close the circuit. Now there's so much current in the battery that if I actually touch this, I will burn out the LED light.
Okay.
But if we make a path out of graphite by drawing on paper, we can make a path that these electrons can travel through, and they can complete the circuit and light the light bulb. So you can
So
see,
not too much power.
not too much power, yeah. You don't want to short out your LED bulb, but just enough to light it up.
Got it.
So
And these graphite pencils are just from a local art store.
a local art store, and the soft ones I discovered work the best. I think just because they coat the paper smoothly. So the idea, if you're making a path for electrons, you don't want any breaks in that path, right?
Right.
So you want a nice thick line for the electrons to travel along. And you just go ahead and clip your LED light, one of the wires into one of the clips. If this doesn't work, just flip it around.
Got it.
The electrons have to travel in one direction or the other. So you can see we've just drawn a line here. Can you see that?
Yeah.
And I'm just going to touch this side. Can you see that? I just touched this side of my circuit to the graphite line, and it lights the light bulb. And the closer I get, the brighter the light gets. Can you guys see that? Now these girls are already experts at this.
Yeah.
They've been doing it for a while. But you can see that if the path is broken, there's only a smudge between these, that you can't continue, the electrons can't travel because the path is broken.
You have to close the circuit.
Yes, but a cool thing to see is if kids draw it, like you drew a heart, right? Do you want to show us what happens? Electrons don't have to travel along a straight path. So if I make a bendy line like this, I can still light my light bulb.
All right.
Because the electrons can still travel. Okay, do you want to try this now? Are you going to try it on your star? Okay, I'll let you finish your star first. We can try it on your little Happi House. Whoa.
Mine is like,
Is yours lighting?
no.
It might have, if it touched the wire, it might have gotten burnt out. So just try a different LED. Okay, try switching.
Oh, yeah.
Switching wires and try it again. Some of these bulbs are burnt out too. There you go. Is that working?
Oh, look at that.
Okay, now get closer to it and see if it gets brighter. Yep, there you go.
I love it.
Do you want to try it again, Penelope?
Do you want to try it? Do you want to try to light up this heart with the red?
Are they all burnt out? Here, let's try it again. Okay, so this is just a really cool way that kids can safely play with electrical current and make their own little
As
circuits at home.
Penelope traces the heart, you can see it getting brighter. Did you see that getting brighter?
It was so cool. All right, so do you have any questions about our little paper circuits? And people are actually starting to print paper batteries using 3D printers.
I've heard
onto
about that.
paper, so.
Yeah, it's crazy.
The 3D circuits, sorry.
I just want to say also, these graphite pencils, we did circuitry with them today, but just as far as an art supply, very satisfying to use and about like $3.
Yeah, not very expensive.
No,
And yeah, you can do nice shading with them, right? They smear really well. Yes, I love art.
Hey, thanks for being our junior scientists, ladies.
You're welcome.
Did you like making paper circuits?
Yes.
Awesome.
Evie, how about
you, Evie?
She's busy.
So I love projects that combine art and science too, because lots of kids, it's a great way to get kids into science is using an art project like
It
this.
is really a great gateway. Thank you, Liz.
Yeah, thank you. Sometimes things don't go the way you plan. Lots of times you have to try science experiments over and over and over to get them to work, but the end result, totally worth it.
Yes.
And it teaches kids problem solving. I have a 60-second science experiment from my new book, Outdoor Science Lab for Kids. How does that sound?
Good.
So this is cool. It doubles as kind of a magic trick. And we even need cards to do it. So pick a card, any card. All right, I'm gonna pick one too. So have you ever heard of atmospheric pressure?
No.
Imagine all the air above us. Look up. Look at all that air. All that air pushes down on us. It's kind of like living at the bottom of a swimming pool full of air.
So gravity?
Gravity, yes, gravity is weighing all these gas molecules down. Exactly, you are super smart. So we're gonna put some water in our glasses and we are going to try to see atmospheric pressure, use atmospheric pressure to hold these cards upside down on our glasses. So we are going to put our card on top of our glass like that, that's right. Try to cover up all the holes in the glass so no water can get out. Okay, put your hand flat on top, like, okay. Oh, you can do it. All right, now we are going to flip it over like this. And now we are going to take our hand away. Oh, we'll try it again, no problem.
Do it.
Okay, we'll try it again. So what happens is all that atmospheric pressure is pushing up on the card even more than gravity is pushing the water down on the card. And that holds the water in the glass. And just remember, if your experiment doesn't work the first time, try it again. Science is all about making mistakes. There's no water in there. So the main thing you need to do, and you're doing great, it's just you just need to make sure that this cup's a little big. So when you flip it over, make sure that no water can leak out, okay? All right, so take this. I'm gonna give you some more water. That's right. Okay, put that in there. Okay, now go ahead and put the card on top. Hold your hand flat. Cover up all the holes in the cup. Okay, go ahead and flip it over. That's right. Now take your hand away. Almost. Here we go. You know, let's use this one and let me dry it off. Maybe it's leaking a little because it's wet. Okay. I promise you this will work. Okay, now take a card, put it on top, keep your hand flat, that's right. Cover it up with the card. Nice. Now carefully flip it over. You got this? Yep. All right, nice. Now take your hand out from the card. Awesome, woo! Atmospheric pressure at work, pushing the card up against the cup. The surface tension of the water also makes the water molecules stick to each other, and that helps hold the card on the glass. What do you think? Is science awesome?
Yeah.
Is that a cool magic trick?
Yeah.
Nice. Try it. For this and other fun experiments, grab a copy of Outdoor Science Lab for Kids.
It's science time on the Happi House. We are with Liz Heineke, one of my favorite scientists because she's so fun. Liz, you're so fun.
I am? Yay!
And we have 2 junior lab assistants. Actually, they probably know more than me. I'm just along for the ride, but.
I think they know more than me, actually.
So we are going to do an experiment today, and honestly, I have no idea what it is. So teach me, teach us.
Okay, this project is called Vegetable Vampires. Can you guys say vampires?
Vampires.
So what do you think that plants drink? Something we drink? Something in water, yeah. Plants drink water. But how do you think they suck it up?
Roots.
Yes, they suck it up from the, see, she's smart. They suck it up through the ground, through their roots, and then they carry it up into their leaves using something called capillary action. Can you say capillary?
Capillary
Action.
action.
Oh, you got it. That's fantastic.
What exactly is a capillary?
A capillary is a long, thin tube, and plant cells are actually long and thin. And physical forces, water molecules like to stick to each other. So physical forces allow the plants to draw the water up through these long, thin cells.
Okay.
So this is called capillary action. And we can observe this by using a Napa cabbage. Does this look delicious? They're pretty good in salad, actually.
That looks delicious to me, honestly.
Yeah.
I'm kind of a veggie nerd, though. I like veggies a lot.
Yeah, they're super delicious. And this, the cool thing about these is they're really light colored, right? So if we put food coloring down here in some water, we can watch the plant drink up the food coloring. But first what we have to do, so parental supervision required with this, I'm gonna do it. We're gonna cut this off at the bottom. We're gonna give this cabbage a fresh cut. You can see I put a rubber band around the top to hold it together. And then I'm actually gonna cut it right down in the middle. So I'm dividing these leaves into 2 parts, right? So now this one piece of cabbage, this one cabbage plant can drink up 2 different colors of water, right? And I'm gonna put a rubber band on each of these. Now what I would like for you guys to do while I do this is put a bunch of food coloring. You can have blue and you can have red. Put a bunch of food coloring in this water for our plant to drink up.
And this just pops off. It seems like it should twist, but it.
Yeah, it pops off. And you need a lot, so you'll be able to see it. If the water's just pink, you can't really see it very well.
More is more.
More is more. Okay, more. And kids love food coloring, right?
Who doesn't?
They can't get enough.
Yeah.
When I say put 1 drop in, usually kids put about 4.
Is that
So,
good?
yep, you can put about 20 drops, couple more.
Ooh. This
Okay,
blue is
so
shaping up over
How
here.
fast do you think the plant's gonna drink up the water?
I don't know. Maybe sort of slow.
Do you think so? Well, we're gonna test that. So let's put.
Do you think fast?
Fast? Do you think it would drink it up in 1 hour or 1 day? All the way from the bottom to the top. Bottom to the top. How long do you think it would take?
An hour.
Okay, well, we're gonna test that. So what we're gonna do, but first I think our vampires need some eyes. What do you think?
For sure.
So you can use red peppers and olives and whatever you want and decorate your vampire faces. But what you guys are gonna do is each of you is going to stick toothpicks. We're gonna add a couple eyes to our vampires. So here you go. Can you stick that through there? Here you go. Here's another one. Okay, so this actually does take a little bit longer. Usually you get the best results overnight.
Okay.
So once you get the eyes on, that looks awesome. Okay, let's put your other eye on.
It's perfect. Nice.
You just have 2 Tupperware containers. I'm gonna put them so they can be kind of tight together. Fantastic. We are gonna put our vampires into the 2 different colors of water, and we are gonna let them drink. Now, you can also look at it from the other side. It's a little harder to see because the leaves are darker. Is it drinking it up right away? Can you see it going up yet?
No.
No, it takes a little while. But if you leave your vampires overnight, Happy, can you show us
Yes.
our overnight vampires that do not have eyes on them?
They don't. We should maybe stick some eyes on these.
Yeah, so you can see, girls, can you see how the blue has gone all the way up from down here, all the way to the very tops of the leaves?
That is so cool.
Isn't that cool? So you can try this with flowers. Honestly, I've had the best luck with Napa cabbage. I've tested lots of different things, but let your kids, what else could you try this with? What other plants do you think you could try this with? Like white daisies? Do you think you could make the leaves turn blue? What other colors could you try?
Colors for food coloring?
Yeah.
Maybe
Could you use green?
or green.
Green would be kind of hard to see, wouldn't it? But orange is a great idea.
Yeah. Or
Okay.
it'd be cool to mix blue and red to make what? What do blue and red make?
Purple.
Yeah.
Yeah.
I'm quizzing you today, aren't
Yeah.
I?
So this is a lot of fun because kids can learn, it's biology, right? Do you know what biology is? It's the science of things that are alive. So plants are alive, animals are alive. So this is a biology experiment that teaches you about plant cells. And let's say it one more time. Capillary action. Say it loud.
Capillary action.
This was lots of fun. This would be cool to have out at like a Halloween party or something too.
I made this up as a Halloween project.
Did you?
Yep, yep.
Liz, this was so fun. I just want to let people know that this experiment and lots more, so this experiment is in this book,
Yeah.
your first book, and lots more experiments are in this outdoor book. And it's so easy to make science accessible to kids and also the parents, because I think oftentimes parents are the ones who think it's going to be hard.
It's easier than baking cookies. Most of these projects are, so don't be afraid.
No, it's so great and so easy. Thank you so much for coming here and also, honestly, writing these books to make science accessible to everyone.
Thanks for having me on the show. I need to look on my phone for this.
Oh, Tease.
I've learned from the best science teacher ever.
Who?
At school?
Oh!
Nah.
Did you hear that?
That's so sweet.
I learned from the best science teacher ever, and she said at school. She goes, yeah, all right.
Nice.
All right.
Okay. Coming up next on the Happi House, we're back in the kitchen or pigeon.
The pigeon.
Yeah. Okay.